Oi! Always make sure you mark the curve, people. What is this curve? Read it. The graph below is the graph of the derivative of the function f. That means this curve is f prime. And you could label it like that, or on the y-axis, you can just write f prime. All the y numbers on this curve are the slopes of f. All the y numbers on this curve are the slopes of f. So that means when this is below the x-axis, when f prime is below the x-axis, what is the slope? What are the slopes of f? They are all negative. They are all negative, which means, so it makes a lot more sense now when you come to this. It says find where f is increasing and where it is decreasing. Now, you guys are used to the first derivative test, so let's make one of those right now. If you were making, if you're doing the first derivative test on this, you have a -2 for a critical value. You have a 0 for a critical value. What's another critical value? 2. +2, because that is everywhere f prime is 0. F prime is 0 right there, and right there. And so if you were doing a sine line graph, you would say positive, negative, positive, and then positive. Where did you get those? Okay, in this interval right here, negative infinity to negative infinity to -2. Are we above or below the x-axis? We're above the x-axis. It's right here. That interval is this. And so we're looking at this curve that is above the x-axis. Oh. And then you guys see this interval right here from -2 to 0. That's right here. We're below the x-axis. That's why we're negative. All right. And then we have the next one, which is from 0 to 2. 0 to 2, we're above the x-axis, so we're positive. And then for the last one, we're above the x-axis, so we're still positive. Okay. So now that we're reading this correctly, we can find the intervals where f, not f prime, where f is increasing and where it is decreasing. Okay, I did my sine line graph right here, which is what you guys are used to, or you guys can just look at this beautiful f prime graph right here that they give you. So that means, let's see, increasing. We are increasing from negative infinity to -2. You always use parentheses. Don't use brackets when you're describing intervals. And then we have from 0 to infinity. You don't have to break this one up right here. It's just continuously increasing. All right. The question is, after knowing this, would you guys be able to do a little graph of it? If you know f prime, can you do a graph of it? I'm going to do a little extra here. Let's do a graph of f. Shall we? We shall. Okay. We have important numbers that we got to consider. That's -2, 0, and +2. Because things change when I hit these x values. Okay, you can start wherever you want. We don't have a point on for f. If we did, we would put a point somewhere, and then we'd start from that point and draw our line. Okay, so wait, what's happening before -2 on f? F is what before -2? It is increasing. And then when I hit -2, what do I have to start doing? Okay, so I can go like this. Right? And what happens when I hit 0? We change to increasing. When I hit 2, what happens? It's still increasing. But when I hit 2, something is supposed to happen. Just like when I hit -2 right here, I was supposed to have a slope of 0. And so that means when I hit 0, I should have a slope of 0. And I'm going to be increasing. And then when I hit 2, I have a slope of 0. And then I continue to increase after that. So that is roughly what our f function looks like. That was kind of nice. It's not perfect. Okay, so let's read our next question. It says, find all local maxima and local minima. Hey, good question over there. So local max and local minima. Now, I don't need this curve right here to answer this question. I can tell just by looking at where we're increasing, where we're decreasing. You see right here, we're increasing, f is increasing, and then it's decreasing. And so see, this is what's happening. So this right here is a local max. So find local maxima. So I would say x equals -2. That's a maxima. What about local minima? We have a local minima as well. That would be at 0. X equals 0. And I could tell that just by looking at this. Because if our curve is decreasing, then increasing, decreasing, increasing, that's going to be a minimum. All right? Then this last one says, if f of -3 equals -2, sketch the graph of f. Oh. Now, what I would do if this was my homework assignment, I would just go straight to this right here, this graph, and I would graph my f curve over the f prime curve. But I always thought that was kind of confusing for people that were just learning how to do this. And so I'm going to draw a new graph. It's kind of crooked, but I don't care. 1, 2, 3. We're at -3. That's going to be a -1, -2, 0, 1, 2, 3. 1, 2, 3. All right, now we have a point. We have a point for f. See, f of -3 is -2. When I plug in -3 to f, I get -2. So I'm going to put my point right 1, 2. -2 right there. So this is my f function. It is a more accurate. This is going to be a more accurate curve than this guy over here. So I'm starting here, and then it says sketch the graph. Now, some people have a hard time knowing, well, how high do I go before I hit -2? I mean, like, we know that we're increasing before we get to -2. We're increasing because the f prime is above the x-axis. So, like, do you go like this, or do you go like this, or do you go like this? Like, what do I do? You know, because all of these can have a slope of 0 right there at -2. Well, how positive are we? Are we really positive at -3? Is it a really steep slope? Yeah, we know because the point right there, is really far away from the x-axis. So we know we're really steep right at that point. So we're going to go high on that one. And it doesn't matter how high you go. You just know you're not going to do that. That's not enough, okay? It should be more like something like that. And right when I get to -2, which is a changing point right here. That's not an asymptote. I'm just saying I'm changing right there. I should have a slope of 0 right at that point. And then, right at -2, that's when my slope starts going negative. Now, do I get really, really negative? No. You see how far away from this is compared to this? Right here, we're really steep. This is not that steep. Okay, so we should just be like, a little bit. And then when we hit 0, we need to curve off. Maybe that's too much. Yeah, right about that. I don't know. It doesn't have to be perfect. So when we hit 0, we're then going to start increasing. Not that crazy. We don't get that far away from the x-axis, so that's bad. Hold on, let me do this again. Okay, that's good. Yeah, I like that. Okay, and then we're going about right there. And then right when I hit +2, I should be 0 again. But what happens after +2? I stay positive. And so now I'm going to start increasing again. And it gets really steep really fast. So right there, slope of 0. Right there, slope of 0. And right there, slope of 0. Because that's all my x-intercepts on f prime. And that is a more accurate curve than this guy over here. But notice how the curvature is still kind of the same. Yeah?